So in this video we will study two more examples related to solubility product and metathesis reaction to know that the solubility product of the gadolinium hydroxide is 1.8 times 10 to the 23. So this is the value is given for KSP. If the solution is 0.01 molar in gadolinium ion and the pH of the solution is slowly increased, at what pH of the gadolinium hydroxide begin to precipitate? So how we can solve this question? That we will write the gadolinium hydroxide equilibrium first. So this is solid and it will dissociate into gadolinium 3 plus, and then 3 hydroxyl ion will come, and then we have, so now they are saying that pH is keep increasing, means we are keep increasing the hydroxyl ion in this reaction mixture, and at what pH gadolinium hydroxide will start precipitating, means at what pH the equilibrium will shift toward the solid reactant side and all the gadolinium will precipitate rather than into ions. So for this type of reaction, first we will write the KSP value, gadolinium ion and hydroxyl ion cube, and then we can rearrange, then hydroxyl ion concentration cube raised power 3 will be equal to KSP over gadolinium ion. Now we can rearrange this equation. So hydroxyl ion will be equal to KSP value and gadolinium ion in parenthesis raised power 1 over 3. So after that, once we will get the we can place all these values, KSP value here and gadolinium ion concentration here, and then take 1 over 3 power. Once we will get this hydroxyl ion concentration, we can take the P, we can get the POH of this one. And how we can get the POH for this one? We will take the negative log of hydroxyl ion concentration. Once we will get the hydroxyl ion concentration, we can plug in this equation to get the POH. Once we will know the pH, POH, we can get the pH for this reaction by subtracting the from 14. So this will become POH. I use this 90 number as OH. So this is the one strategy. Here you can try with your own. I am just leaving this for you guys. And there is one more question to understand that assume that sodium 0.1 molar sodium fluoride solution is added slowly with stirring to a solution that contains 0.1 molar chromium nitrate and 0.1 molar calcium nitrate. Which salt, chromium fluoride or calcium fluoride, precipitate first? So here you can understand like this one, that we have one tube of test tube and that has chromium nitrate plus we have calcium nitrate, right, and we are adding slowly sodium fluoride in this solution. And so which salt will precipitate first? So here we are going to compare, and KSP for calcium fluoride and KSP for chromium fluoride is given. So what will happen? This is again precipitation reaction and metathesis reaction. Chromium nitrate will react with the sodium fluoride to form chromium fluoride and sodium nitrate, and calcium nitrate will react with the sodium fluoride to form the calcium difluoride, or we can say calcium fluoride, and then sodium nitrate. So these two reactions will occur. Once you write the reaction, make sure it is balanced, that is why. And once we will balance the reaction, then we can start comparing, that basically all the nitrates will remain dissolved. We have to pay attention on these fluorides, chromium fluoride and calcium fluoride. So we'll study one by one that which fluoride will precipitate first. So chromium fluoride will dissociate into chromium ion and 3 fluoride ion. Ksp will be chromium ion and fluoride ion cube. Fluoride ion will be equal to Ksp over chromium ion raised power 1 over 3, and then fluoride ion will be equal to Ksp of the chromium fluoride is given in the question, and molarity of chromium nitrate is given. So we are going to use that one and plug this value and find out fluoride concentration, which is 8.7 times 10 to the power 4. So for case of chromium fluoride concentration we figure it out here, and in case of calcium fluoride so calcium fluoride, here we will find out fluoride ion concentration with the calcium fluoride. So calcium fluoride will dissociate into calcium ion and 2 fluoride ion. So Ksp for this one, calcium ion and fluoride ion square. Fluoride ion will be equal to Ksp divided by calcium ion raised power half, and then fluoride ion concentration will be calculated by using Ksp and their calcium nitrate concentration, and this will give us the value for the fluoride ion. So now you can see, if we will compare these two fluoride ion concentration, so here this will be 3 fluoride. So basically fluoride ion concentration will get fluoride ion concentration is 8.7 times 10 to the minus 4, and in this case fluoride ion concentration will be 2.3 times 10 to the minus 4. It means there is a less fluoride ion in case of calcium. So it means calcium is ionizing less than the chromium. That is why calcium fluoride will precipitate, will precipitate first, basically, not the chromium fluoride. So this was the example to compare, how to compare the two metathesis reaction and how to predict which salt will precipitate first.